Welcome to the Medical Independent Innovation in Healthcare podcast series, where we explore the advances that are transforming Irish healthcare and the innovative minds behind them. From cutting-edge technologies to groundbreaking research to new models of care, Ireland is at the forefront of medical innovation. Our guests are leading figures in the Irish and international healthcare community who are revolutionising the way patients are being treated. So whether you're a healthcare professional, a patient, or simply curious about the latest developments in Irish medicine, join us for an engaging and informative discussion.
Hello and welcome to the latest episode of the Medical Independent Innovation and Healthcare podcast series. I'm your host, Priscilla Lynch, Clinical Editor of the Medical Independent. Joining me in this episode is Professor Derek O'Keeffe, Professor of Medical Device Technology at NUI Galway and Consultant Physician in Endocrinology at University Hospital Galway. Firstly, Professor O'Keeffe, you're both a clinician and an engineer, a physicianeer. Can you tell me how that came about?
I suppose a physicianeer is somebody who has had training in medicine as a physician and also in engineering. And that's definitely my background. So I guess it all started, from a kind of childhood of curiosity. I remember back when I was 12 or 13, seeing a blackbird in the back garden with a broken wing and, trying to think about how to help it or fix it, the broken wing. And at the time I had to go to the library and get a book and figure out how to make a splint, and came back and was successful then in helping that blackbird ultimately fly away after a few weeks. And then I remember another period later on, this is the 90s, so it was unusual to have a second television. So we got a new television in the house, and the old colour television was going into the back room for my dad to watch. And he was at work one day and I was off for the summer because I would have been just probably in fifth year or something. And I took apart the television because I wanted to see how it worked. And so when my dad came home, he was like, "What have you done to my spare television that I was going to use for sport?" And I explained that I wanted to, see how it worked. And I got a book out of the library to figure out about CRT, cathode ray tubes. And he said to me, "That's great, but you need to put it back together." So I put it back together. And then unfortunately the colour television was black and white. Now it still worked, but it meant that he had to watch sport in black and white for 6 months. And so he said to me at the time, "You need to go to college, kid, figure out how to fix things properly." So I did. I went to college. I did electronic engineering at the University of Limerick to understand about electronics and so on. And then I did a master's of computer engineering to figure out how computer engineering works. And then I had used both of them in applications of biomedical engineering. So I did a biomedical engineering PhD. And when I finished that, then I got a great opportunity to go to America, to Harvard, to do a postdoc there. And, some people may not realize that in America, you do medicine as a graduate program. So that means you don't come straight out of high school or secondary school. You normally do a degree in something else like science or arts or engineering. And the particular group of people that I worked with in Boston, they had done their engineering at MIT and then were coming to Harvard, where I met them for their medical degree. So they were on this kind of physicianeer stream. So they had said to me at the time, your engineering is pretty solid. It's engineering, it's electronics and computers and biomedical. But you're missing this whole other piece of the clinical world and what's really important, and that you should do it. And it's one of the great things I learned in America at the time was that mantra of just do it. You meet so many people in life that are kind of mañana people, as they say in South America, that, it's tomorrow, it's mañana, I'll do something tomorrow. But certainly one of the great assets of the US is just do it, as it says on the Nike sneaker. So just do it. So stop talking about it and do it. So I actually said, okay. So I'm back and did medicine then. Because, you got to remember I was in my mid-20s and I just finished a PhD and I thought I was finished really. And then, this whole other education opportunity opened up. So I had to make some big choices about what I was going to do. So I went back and did medicine then, which was a fantastic thing. And then did some of my training here in Ireland, my clinical training, because when you finish your medical degree, you still have 10 to 15 years more training to get your clinical experience. So I did some of that in Ireland, and then I went back to America again, to Minnesota, to the Mayo Clinic, where I completed my residency, as it's known, and then my fellowship in endocrinology. And then I came back then and got a permanent job eventually in Ireland in August 2018. And my father cried. He was so happy that I got a permanent job after going to college. So he said to me, told you go to college, kid, but not for 20 years. So
been some journey. And I mean, I suppose people would see that you have to pick one or the other, being an engineer to fix things, going into medicine to fix people, but they're really complementary to each other. And I suppose also endocrinology as well. Why did you pick that particular specialty, I suppose, of all others?
Yeah, it's a good question. So I suppose the first thing is engineers tend to be very logical and solutions orientated and systems thinking. Um, and they're always looking for problems to solve, I guess. And clinicians, people who work in the medical world, always know that it's full of problems and it's a spectrum of decisions to make. So when the two of those meet, it gives you great opportunity for innovation. Um, and I think that's one of the big reasons why this fusion of engineering and medicine is very useful. Personally, the reason I chose as a subspecialty endocrinology is that the human body obviously is a type of machine, obviously a very refined machine, and the body really strives to keep the machine working properly. So if you think of it like what I call the Goldilocks framework, that everything in your body, it's kind of like Goldilocks. It can't be too hot, it can't be too cold, it has to be just right. So be that the sodium levels in your body or the sugar levels in your body, there's this really beautiful U-shaped curve that if you have too much of it, your mortality goes up. And if you have too little of it, your mortality goes up. But right in the middle, that sweet spot, that Goldilocks spot, as I call it, the body strives to maintain that homeostasis. And it does it through feedback mechanisms. So, for example, in endocrinology, if your sugar is too high, you secrete insulin from the pancreas. If your sugar is too low, if you have hypoglycemia, you secrete glucagon. So that is very much in keeping with the mindset of engineering. A very simple example being a thermostat. When the room's too cold, the heater comes on. When it's too hot, it knocks off and opens a window or something. So that's the principle of engineering, that kind of like systems thinking and feedback. So that's one reason. And obviously endocrinology is very maths orientated with the kind of things it deals with electrolyte abnormalities. And then on a personal note, I think in endocrinology, a lot of the disease in endocrinology, we actually have treatments for. So like a lot of physicians, I thought about doing other specialties as well as I was going through my training. But one thing that drew me to endocrinology is that we actually have treatments for many of the major diseases. So if you are unfortunate that you get type 1 diabetes, for example, we can figure out that you have that. But then also we can offer you a treatment for that with insulin. Unfortunately, what lots of other subspecialties in medicine, they can diagnose very unusual conditions, but they often don't have treatments, which is very frustrating for the clinician and then also for the patients, obviously. So endocrinology for me was that nice blend of both. So and then the position that I got here as a consultant in 2018, it was one of this new type of consultant whereby it's an academic consultant. You have a dual appointment in a university and in a hospital environment, allowing you to kind of harness the best aspects of both in your clinical practice. So in my world, I'm a professor of medical technology at the university. I have a research laboratory there called the Hive Lab, Health Innovation via Engineering. I teach at the campus, both in engineering and in medicine, undergraduate and postgraduate. And then, we do all the other things the faculty do. We apply for research grants, we do education outreach, and then obviously participate in local, national, and international professional body committees and so on. So it's a nice mix.
So it's the perfect role, really, I suppose, to marry the innovation and the clinical side as well. And, particularly for your profession, as you said, even in endocrinology, there is a lot of med tech, isn't there? I mean, between continuous glucose monitoring, the delivery of insulin, those devices, continuous insulin delivery systems and artificial pancreases. So it's a really interesting time that you've come into that as well, given your unique background.
Yeah, for sure it is. Now, all of medicine, as you know, is undergoing digitalization. But endocrinology in particular, as you mentioned, the continuous glucose monitors, the insulin pumps, all the software, you have so many apps available for patients to use to empower them. I mean, the thing about clinical practice is that we can't be with patients all the time, those who have chronic diseases. And so, for example, if you were to add up all the hours that a patient with diabetes sees a clinical team for over the year, be that the inpatient hospital team, the outpatient hospital team, or even the community team. So, for example, the general practitioner, it's probably only 10 hours a year if you added up all the clinical visits. But, if you think about how many hours in the year, it's probably 9,000 hours. So, for 8,990 hours, they have to actually manage the chronic condition themselves. And a big part of that is giving them the tools, the technology, as we just spoke about, and also the education. So the online resources that are there digitally and the apps, as we mentioned. So technology is taking over a big part of the burden of managing chronic disease. And it's a really exciting time to be in this space. And as an engineer or a physicianeer, when you go about your daily job in the hospital, you actually see so many opportunities for innovation, more than you can possibly, develop projects for. So you end up triaging different projects in your head. And it's kind of similar, just to flag it to your listeners who may not be aware of it. The first thing is that Ireland is one of the great longitudes of excellence, as I call it, for med tech. So if you think about the med tech regions of the world, you're thinking California longitude, Minnesota longitude, Boston longitude, Ireland, then Berlin and Singapore. So we're very fortunate that we're in one of the strongholds in the world for this. We call Galway the Silicon Valley of the med tech world, because 13 of the world's largest 15 medtech companies are here. They all have a massive footprint in Ireland, and specifically around the Galway ecosystem, but in general across Ireland. First of all, that gives a tremendous resource for the university and the hospital to interact with those industries. And those industries are here for a good reason, because of the hospital and the university and the graduates. That's the first thing to say. The second thing is that through the good work of the government and Enterprise Ireland and so on, and IDA, those companies are here, and we're putting together this really exciting ecosystem of trying to bring innovation into the hospital and also innovation out. I'm very conscious that a lot of my colleagues may not have the skill set to develop a product, whatever that product is, software or hardware. And so thankfully, some institutions have been put in around the hospitals in Ireland called the Health Innovation Hub, HIH. .ie, I think, is the website if people want to look it up. And that is exactly that. That's a place where clinicians can go with an idea that will connect them into the local, innovation infrastructure. And also companies can come there to find out how they can test a product, in the hospital, to connect them with the right clinicians. That's a really interesting thing that's happened in the innovation space in the last 5 years. And then another thing that's worth noting again in Galway is we have the BioInnovate program. And this is a really exciting program based on a Stanford model called biodesign, whereby every year we pick engineers, people with business backgrounds, people with marketing backgrounds, and physicians to join a team. And that team then goes into a hospital, and, for example, they follow the cardiology team around for a couple of months, and they write down 500 problems that the cardiology team has every day in its job. And then what they do then is they refine those ideas over the year, which ideas are actually technologically feasible to build, which ones have a market for them to be sold to, and then which can they make for the right price point. So by the end of the year, that BioInnovate team has one really exceptional idea using all the skill sets of the team that they can go on then in partnership with, for example, Enterprise Ireland, and do a spin-out startup company. We've had a lot of success with that. So that's a really interesting model or framework based on a really successful US model. And that's led out of Galway by people like Professor Martin O'Halloran and Professor Faisal Sharif, and some really great colleagues in the innovation space. So we're really lucky that that's here in Ireland. It's not there by accident. A lot of good people have put work to put that in place, but it really makes for a very exciting clinical environment whereby if you see a problem, you have an opportunity to develop a solution for it.
Absolutely. That's really encouraging, because over the years, many doctors and nurses and other healthcare staff have told me about various ideas that they've had to improve patient care and to make life easier for clinicians as well. But how do you bring something from bench to bedside? It can be a real struggle to try and find that support, how to pilot it, how to implement it. So you have the infrastructure in Galway very much, it seems, to absolutely bring that from the beginning of an idea absolutely to fruition. So that's very encouraging. And not only that, about having those companies in Galway, you've personally been involved in the development of some educational initiatives at the university. There's a physician-ear program now specifically in Galway, and there's also a master's in diabetes. Can you tell us a little bit about how those programs came about?
Yes, so as a university, our job is to respond to the needs of society, and one of them, as you mentioned, is this idea of a dual physician engineering program. So that has been developed with my colleague, Dr. Ted Vaughan, in biomedical engineering. So Galway already has a world-class biomedical engineering faculty and a medical faculty. So it was the next natural thing to kind of fuse those two together, people who can see the benefit of those two worlds interacting and having graduates in that stream. So there is one or two physician year programs in the world. As I mentioned to you, there's one in Boston. There's another famous one in Northwestern University in Chicago, where you do engineering first, then medicine afterwards. There's one in Singapore. There's one in Duke University. There's a few of them around the world whereby that academic institution has kind of realized the benefit of having a streamed approach to engineering and medical training. And you have to remember that in Ireland, to get a biomedical engineering degree, it's 4 years. To get a medical degree, it's 5 years. So that's kind of a 9-year program if you did them back to back. And what we realized then through our collaboration is that we could streamline the program to an 8-year program. So obviously with this kind of an ambitious program, we have to get a lot of stakeholders involved, including the health service, the Department of Health, the HEA, and everyone else, all the different stakeholders, to make sure that we can actually do this and that we can respond to the needs that industry are looking for. Now, take in typically about 200 medical students a year into a medical program in Ireland, undergraduate medical students. And for sure, we don't want all 200 medical students to be physician years because a lot of them, have to do the regular day job of the hospital or of GP care and so on. But there is a subset of students every year, which sounds remarkably nerdy when I say it out loud, but there's one or two students every year who come to us at the end of first year and say, look, I really like medicine, but I actually miss applied maths and physics. Because as you can imagine, when you come into medicine, the focus is more on biology and chemistry. So there are those students there who have that kind of dual mindset and the ability to, to think in mathematics and to be quite logical. And so we thought there was a need. We did our research and then we developed this course which launched last year. So we're just taking our first students into that course. And after 8 years in total, they will come out as physician years, so dual qualified in engineering and medicine. And then those people can, for example, go on and do research programs, so masters or PhDs, or continue on into the clinical world to become, interns, SHOs, registrars, and so on, ultimately consultants. So there will be a mix. And I guess I should say as well up front that there's a lot of physician years in Ireland anyway, besides this kind of official program. So because of graduate medicine entry coming into Ireland over a decade ago, there would have been people in Ireland who have done engineering or IT or something similar and then went back to do graduate medicine either in Dublin or Limerick. So there is a lot of physician years out there. Even in this hospital, a lot of my colleagues have done medicine as an undergraduate, which is great. And then also, I meet so many physicians who really are physician years because of the way they approach problems and so on and the solutions they develop. But this is certainly a really exciting, innovative, first in Europe physician year program. So it's great for that to come out of the University of Galway. And then separate to that, then you mentioned the diabetes masters, and this is a really important clinical part of the way we think about healthcare, is that we need to have specialized clinical staff for the diseases that need attention, and one of them is diabetes. Your listeners might know that there's roughly 600 million people on planet Earth with diabetes. That's a tsunami of a public health disease and crisis. So it's probably 1 in 10 of the general population. If you come into a hospital, it's probably 1 in 6 of patients we see. If you're up in the CCU, the coronary care unit, it's probably 1 in 3 patients. If it's after coronary artery bypass graft or coronary stenting, it's probably 1 in 2 patients. So depending on which population you look at, it's more prevalent. But the principle is it's very prevalent chronic disease, type 2 diabetes especially, and therefore it needs specialized staff that have expertise in that area. So we set up a master's program both for clinicians who are medically focused. So for example, physicians or dietitians or podiatrists, people who may want specialized training in diabetes after their professional qualification. And then we also set up a specific one for nurses, so a diabetes nurses master's course. And both courses you can exit after a year as a graduate diploma, which is worth mentioning. But both those courses were set up to address the potential skills that we'll need in the next decade and beyond. So we're trying to be strategic in our thinking, and already it's really paid dividends. because again, a lot of your listeners might know of something that's been rolled out across the country called the Enhanced Community Care Hubs. So I am actually onto a new role as the National Clinical Lead for Diabetes for the HSE. And part of that is the rollout of these hubs, which is delivering specialized chronic disease management in the community for diabetes, respiratory, and cardiology. So that would be COPD for respiratory and heart failure for cardiology. So these three chronic diseases represent the vast majority of kind of morbidity, and therefore the government have put in specialized resources in the community for that. And therefore we do need to have specialized staff to fill those posts in the community as well as in the hospitals. So it's an exciting time to be in the diabetes space, both from the technological point of view, but then also for the clinical skills that are needed. And thankfully, the University of Galway is taking a leadership position in developing those courses.
Absolutely, and there's huge demand, obviously from a patient point of view and from clinicians as well, who are trying to get that specific expertise. And along with that education as well, a lot of the projects that you're involved with at a research and a med tech level are all about chronic disease management and improving care. So could you tell me some of the more interesting projects? I know you have a number of robotics projects, for example, on the go.
Yeah, we do. So we've been fortunate. So since 2018, so I realized pretty quickly, even though I'm well trained in engineering and science and medicine, um, I actually decided to do an MBA during COVID part time. And my father nearly cried again because I was going back to college, but I explained to him I would do it part time on Sundays and Saturday mornings. But I did it because I wanted to understand a different aspect of healthcare. And the best way I can explain the rationale for doing the MBA is that if you have a patient, for example, down the emergency department, and they have a cut on their leg, make it simple like that. As a clinician or a doctor, you go down to the patient, you see they have a cut on their leg, and you say, okay, they're going to need a dressing or a bandage, and they're going to need antibiotics. So you do that, you write them a prescription for antibiotics. As a biomedical engineer or a physicianeer, you go down and you say, okay, this person needs a bandage and they need antibiotics. Is there a way I could put the antibiotics into the bandage? Do both together? That would be a very efficient way of doing it and providing the antibiotic coverage locally to that area as opposed to systemically through a pill. As MBA lens, if that's the word, you think of the systems that you're in, the healthcare system and systems thinking, and you think, should this person even be in the emergency department? Should they not be managed at an urgent referral center, in the community? So it's more about how the system of healthcare is. And that's been very instrumental in my thinking about the whole healthcare system and the way it's delivered, and the follow-on now for this national lead in diabetes and how we structure and roll out the delivery of care for this significant public morbidity of type 2 diabetes. So back to the research again. So you mentioned earlier the traditional way of doing science research is, bench to bedside. But one of the great opportunities of being a clinician and trying to help patients at the moment, given current, treatments and guidelines, as you do as a clinician, is trying to see, is there new ways of developing treatments for patients? And therefore, what we try and do here in Galway is bedside to bench to bedside. And again, back in 2018, when I took up my position, despite my training in the three different areas, I have massive blind spots in engineering, medicine, and, kind of business thinking. But also these other blind spots that I have in educational delivery or pedagogy, in psychology, in computer science, in lots of different areas. So I decided I'd start something called this Hive Lab, because if you think about it, no one honeybee makes honey. It has to work in a hive. And ultimately, as a species, we all work better together, not as individuals. So I think it's very important to be aware of your blind spots and to be open to collaboration with other experts. So we've done that in the Hive. We have over 30 people that collaborate with us across the university here and nationally and internationally. And because of that, then we were able to do some really exciting projects, which you mentioned there, which we might talk about one or two of them. I guess an early result for us that put us on the map as a lab, and we're very lucky as a lab that in the last 5 years, we've been honoured with really good funding from Science Foundation Ireland, from the Health Research Board, and then also from industry partners such as Cisco, for example. But one early project that we did was with what's called the diabetes drone. And that was a really great project because it really was an example of a clinical problem that came up with a solution that was actually a world first. And The project itself was featured in the British Museum of Science in London as a hallmark to its innovation. And the problem really arose, if you remember, back in 2019, I think it was, with Storm Ophelia. This is BC, 2019 BC, before COVID, when the biggest issue we had to worry about wasn't a viral global pandemic, but rather, really bad weather, whereby a lot of people in the west of Ireland were flooded into their farms. So I went to my regular clinic on a Tuesday morning, and I was greeted by the admin staff telling me that people had already rang in saying they weren't going to be at the clinical appointment at 8 o'clock. And this had happened for 30 or out of the 50 patients that were coming. And that was only, 8 a.m. or 10 to 8. So over that morning, we realised that only about 5 patients out of the 50 turned up, because all the rest were flooded in across the west of Ireland. And patients were ringing then saying, can we reschedule the appointment, which was no problem. Of course, we were doing that. But the other thing they were saying is, Doc, I've got type 1 diabetes. I have insulin here at home, but I'm running out of my supply, and I was going to come into the clinic and get a prescription off you today, and now I can't, and I'm also flooded. How am I going to get my insulin? And your listeners might know that for type 1 diabetes, insulin is a life-saving medicine. So you need to take it every day. Like in Addison's, you need to take steroids every day. And it made me pause for a second and think, well, how are we going to get insulin to all these patients across the west of Ireland who need insulin and they're running out of it? And the only thing we could do at the time, I remember specifically that, thinking, what will I do? And then I said, all I can do is really check the weather forecast to see, is the weather going to get better? And thankfully, the storm was passing at that stage, and the weather was scheduled to get better, which means the floodwaters would dissipate. And that's what happened. Ultimately, at the end of the week, the storm got better. People could get to their pharmacies. So we literally told people, wait a day or two, use the end of your supply, and then hopefully by Friday you'll get to your pharmacy, which is what happened. But it did make me think afterwards, what would happen if the storm had continued or the flooding had got worse? And the only way I could think about, has this happened before, was do a literature search, which is what we do all the time in the research world, and figure out how it happened before. And the biggest example I could look at was Hurricane Katrina, which happened about 10 years previously. I think it was 2007 or 8 in the US, New Orleans. Massive flood, obviously, a lot of morbidity and mortality associated with it. And unfortunately, those people with chronic diseases, they just perished because they weren't able to send a helicopter to everybody. So I thought about then, as a physicianeer, was there a way to fix this? And obviously at the time in 2019, drones became commercially available in toy shops, for example. So in principle, you could take an insulin pen and you could fly it across your back garden and say that you flew insulin across your back garden, that you delivered insulin. But I mean, that's not really a practical solution, because what we're talking about is delivering insulin over the horizon. But as I started to read into it, I realized that flying drones beyond the horizon was illegal, and you're only allowed to fly a drone where you can visibly see it. That's the whole idea, that it's under your visible control. So as I looked into the regulations around that, I realized that the only people really flying drones beyond the horizon were the US Air Force, and they weren't dropping insulin pens. So nobody was really flying drones beyond the horizon in civil airspace in the Western world. There was 1 or 2 companies that just started in Africa, but they're flying drones, largely over jungle, so there isn't any other aircraft around that could be a concern. So that was one regulatory issue that we had to sort out. The other regulatory issue is that, insulin has to be prescribed. So who can prescribe it and who can receive it? There's a reason in Ireland why you don't get your medications through the post, which would be very easy, obviously. But the challenge is that you don't know who's going to open that parcel and inject themselves with insulin or take your pills in error, for example, a young child. So we had to figure out that regulatory issue. The other thing we had to figure out then is the pharmaceutical regulatory issue, in that there is a cold chain whereby medications have to be delivered at a certain temperature and in a certain chain of custody. So we basically sat down and we set this as a clinical problem, and we formed stakeholder groups with all the different people. And over the course of about a year, we managed to address all the issues and put in redundancy in the project, whereby then we found a drone we could fly. And in this case, we chose a real world example of the Aran Islands, because that's 20 kilometers off the coast of Connacht. So if we could fly it out there, we could really fly it beyond the horizon, under sea conditions and so on. So we did that mission. We flew the drone under AI out to the island with a drone pilot backup at all times, being able to see the video feed and step in if there was a problem. We are able to have redundancy for the communication. So if the cellular comms went down, we had satellite comms backup. we were able to deliver the insulin to the island and take a blood sample back. So it was a really great example of a proof of concept. And since then, there's been a lot of companies obviously commercially getting into the drone space. So there's Google have their Flight Wing, Amazon had a drone company for a while. The great success though is the Irish company Mana, great name for a company, Mana from Heaven, the Mana drone company, which in 2020, 2021 in the pandemic actually operated out of Galway and Oranmore. And we're actually partnering with Bobby and his company Mana this summer on another exciting medication delivery project. So that's a great example of the diabetes drone, a clinical problem coming up with a world first solution to address all these regulatory issues. And it was complex, but it was really worth doing. And it probably leads me to another point about your mindset when you're a physician. There's two types of people in life essentially, and every morning when we get out of bed, we can decide which we want to be. And that's people with high agency or people with low agency. And can shout and scream and say we're subject to our environment and all these problems, and we'll deal with something mañana. Or we can say, you know what, let's this be our problem and let us try and put a team together to solve it. And so that's a great example of an early Hive project that did very well. And since then, we've had a lot of good success then with publications in the world's biggest journals, in New England Journal of Medicine and the BMJ and JAMA, looking at things like diabetes technology and its clinical use and where that technology might be headed with closed loop and so on. We've done a lot of interesting work, as you mentioned, with robots. Again, driven from clinical need during the pandemic. I would have been in full PPE, obviously, like lots of other people working in hospitals. And I remember specifically coming down at one stage, this would have been in the first wave when there wasn't vaccine rollout. So it would have been like around, April, May 2020. And coming down and seeing people come into the hospital and not wash their hands. Now, they could have washed their hands in their car, or maybe they were just like most people and were just, too distracted by having a loved one in hospital and were rushing in. But either way, I counted 20 people coming into the hospital when I was having my tea break. And of the 20 people, only 10 people actually used the hand sanitizer on the way in. And you'd be thinking, obviously, as a human, why am I wearing all this PPE and stuff and people are coming in, not even cleaning their hands and so on. And you couldn't sit there all day and manage that because you got to go back to the wards after your 10-minute break. So I remember thinking, what would be brilliant if I had a robot there at the door that would just gently remind people, a digital nudge, as it were, to wash their hands. So yeah, that weekend when I was off, I said, you know what, I'll write a grant. So I wrote a grant and I said, this is the idea. Get a robot, program it so that when people come in, it says, hello, would you like to wash your hands? And thankfully the project was funded. We did that, programmed the robot over a couple of nights. And then, within a month, then we had the robot at the front of the hospital and we saw, was there an improvement or not? That was the research question. And there was a significant improvement. So we got that research published, and it was the first example of using robots in healthcare settings to improve a public health outcome, which was really exciting. And we've gone on now and used that robot in other ways in the chronic disease clinic in diabetes to educate patients. We've shown that the robot can educate patients about basic nutritional and diabetes management issues as good as I can or the nurse can. That allows us to free up the nurse and myself to do higher value work on our license, like insulin adjustments and so on. So that's really interesting work we did with robots. And then this summer, we have a really interesting project going on with Science Foundation Ireland and Cisco on Clare Island. So during the pandemic, another example of the robot use case was when only one parent was allowed into the hospital, and that child might have had a new diagnosis of type 1 diabetes. And obviously there's one parent in the car and one parent at the bedside. And often when the parent goes back to the parent in the car, the message isn't clear, because when you're given a big life-altering diagnosis about yourself or your child, you may not remember everything. So we were able to facilitate parents in the car being involved by having a robot at the bedside and having two-way audiovisual communication with the parent outside, or the grandparents at home and so on. So we've built on that then with Cisco over the years, and now we're doing this really exciting project on Clare Island called the Home Health Project. And that's a collaboration between Quorum, which is a big part of the MedTech success story in Galway. It's an SFI centre for MedTech development across all the different aspects, not just the ICT aspect, but also the biological aspects. And that's worth reading about if your listeners would like to learn more. But with Quorum and Cisco and SFI, now we have this exciting project looking at, people living well, which is where we're moving to in medicine, taking the lens off the kind of acute treatment at the end of life and back towards disease prevention. So we're doing a big project around that on Clare Island. And then also chronic disease management. So I did a TED talk back in 2019 called Digital Doctors. And in that TED talk, I outlined that, banking and shopping had basically digitally transformed in the previous decade, and healthcare was the next place to digitally transform. Now, one of the benefits, if that's the word, of COVID is that a lot of medicine has digitally transformed quite quickly. We say that 10 years worth of transformation has happened in 1 year of COVID-19. And so we're trying to build on that now in this Clare Island project, whereby rather than a patient, for example, driving 2 hours from Clare Island, getting a boat from Clare Island, driving 2 hours, coming down to a clinic, parking for an hour, waiting in the waiting room for 30 minutes to see me for 10 minutes, wouldn't it be better to deliver that care virtually? So they can just basically log on, see me in real time over a video consultation link. And then at the same time, here's the interesting part, on the other screen, I can see all their physiological data in real time, and also for the last couple of months. So I can see their blood pressure data, their glucose data, their movement data, their weight, if it's changed, for example, with heart failure patients. So really exciting physiological data that I can see remotely while I'm talking to them. And that makes for a very rich conversation, because I can see when they administered insulin, I can see how their sugar responded, I can see did they go low because they were also out exercising at the time. So it's a very rich conversation. So we've piloted that project well now since last summer, 22. And we're in the middle now of another work package in that project, which involves digital virtual clinics for hypertension management. And there's lots of other interesting things, as I mentioned. There's a drone project to deliver drones. And then that other part that I wanted to mention was the robot. So again, we wrote a grant and we got a quadruped robot. And the background to that is that during the initial phase of COVID-19, when we were all struggling, with this new pandemic, and we weren't sure of the kill rate of COVID-19. If you remember those famous trucks from Bergamo, was the kill rate going to be like Ebola? 50% of people are going to die if they get it? Or was it going to be like seasonal influenza, when it's going to be, nearer, 1%, depending who gets it? And we didn't know that. So it was quite terrifying, that first wave in particular, for a lot of people in the healthcare world. So I was invited onto a lot of expert groups in the US because of my connections there for specialist input on how they would respond to this massive global pandemic. And we were at meetings about setting up tents in Central Park or in Boston Common to deal with 4,000 casualties as it was at the time. And then because, as you know, there was a worldwide shortage of PPE, how would you actually operationalize that? How would a doctor or nurse walk around a large tent in Central Park without PPE on, without sufficient PPE? And so we were thinking about that at the time, and we were saying, maybe we could get a robot to go around and interact with patients, that almost like having a mobile baby monitor that could talk to patients. But one of the immediate challenges was that robots that were available to us in 2020 all had wheels, because they're all designed to work in, perfect carpeted or tiled airports. So having quadrupeds and having data on that would have been really interesting. But at the time, we didn't have that access to us, because again, in the civilian space, that wasn't available. Only really in the military space had access to that kind of technology. But thankfully now it's developed, and we all made at the time a commitment that when that technology came into the civilian space, we'd start to look at medical use cases for this kind of technology. So when the next pandemic comes, which it will, that will be more prepared, and we'll have the right protocols in place, like we do, for example, now for the diabetes drone. So we're doing that this year at Clare Island. It's very exciting. We're going to use this quadruped dog that's called Madra, the mobile autonomous droid for remote assistance. And we're going to use Madra in a whole host of medical simulations that will be run remotely. And this kind of move towards digitally transform the first responder part of the healthcare system is already underway. Several ambulance crews around the world now wear body cameras, so that when they come to a scene, that data can be fed back to an emergency department physician or team to give that kind of specialized input to maybe a unique presentation in the field. So it's coming together, and I guess what we're trying to do all the time is to push the boundary, and this particular home health project is a great example of that. As we move towards other digitalization, ultimately, of healthcare, such as virtual wards and virtual hospitals, which is the direction of travel for the next 2 or 3 years as we roll it out.
Is there no end to your innovation? I mean, that's an amazing array of projects that you've just outlined for us, the details of there. And I suppose they're all really about the heart of improving outcomes for patients, making life easier for doctors, and maximizing your time as well. As you said there's a lot of problems in healthcare that are just inefficiencies really in time and processes. And sometimes, when we think about the most complex solutions or the most complex technology, it can be very simple sometimes as well, can't it?
Yeah, it can be. And you don't always have to reach for the shiny gadget or toy. We're very conscious of that in our lab that, we don't necessarily use the state of the art stuff just for the sake of it. It's all about producing meaningful clinical input and scientific output. So all of the studies we've done so far have had direct patient benefit and have been published in the best journals because of that. Um, and I think that's a really important thing to remember, that it starts with the patient and it finishes with the patient. And if you use that as your central core, that's really important. And another big thing that we've tried to embrace in our lab in the last 5 years is the whole concept of PPI, which is public patient involvement in science. And again, if you think about this historically, a lot of established faculty members in universities around the world would have traditionally gone off in their research directions as they saw fit, might have developed a piece of technology, and then when they bring it back to the actual use case, nobody wants it or needs it, or it's designed wrong. So there's been a real shift in the global science foundations around the world to try and have the patient or the public involved at the beginning. So in the Hive lab, we have a PPI team. So these are patients or members of the public that are on our team that basically are there at the very beginning when we're designing ideas, and they say to us, that's a really great idea, we should do it, or the opposite, which is more useful sometimes, which is don't develop that idea, nobody will use it, why spend a year or two doing it if nobody's going to use it? And it's more about having patience at the part of the project development where you're designing the survey, not just giving them the survey at the end, if that makes sense. So we do really have really good input from that particular PPI group. And then also we have input from patient representative groups as well, like, for example, Diabetes Ireland. I meet with them regularly for their input, both clinically and so on. So I think that's a really new paradigm in scientific research, but it's also really important because it allows research to become translational, not just in a lab. It's actually, going to be, as I said, back at the bedside, which is important. And it's about keeping fresh eyes. I mean, like I said, every day you're in clinical practice, you see new things, and you don't have bandwidth to do it all. So you triage what you can do, and then obviously you bring other collaborators in if they have better skills than you. So that's really important. Like one example I can think of is during COVID. I remember again being in full PPE, that first wave, and hearing people cough. And I remember thinking, God, that sounds like a COVID cough. And then I thought I was crazy for thinking that because, coughs are all very similar. But then there is a biological precedence for that. So you'll all be familiar probably with the whooping cough that has a particular tone and resonance and rhythm to it. But then I'd hear other people and I'd say, that sounds like a COVID cough. And then I'd check the PCR and it was negative. So obviously I was wrong. But it gave me an idea back then in 2020, could we differentiate between COVID and non-COVID based on the cough, for example? And if you remember at the time, for every 100 people that were screened for COVID because they had some symptom, and obviously everyone was hyper aware of having COVID, the success of actually having a positive PCR was only about maybe 5-6%. So for every 100 people you swabbed, only 5 or 10 of them had COVID. That's a tremendous waste of screening, obviously. Now, it was important to do it, but it wasn't a very efficient way. So based on that idea that we had on the wards that day, we put a team together. And some of my colleagues from MIT, they had deep experience in what's called vocal biomarkers. They had developed technology that you could ring a phone number and talk on the phone for a few minutes, and it could actually give you a percentage risk of whether you had Parkinson's disease or not, based on your voice pattern. So I collaborated with them and with Dr. Andrew Simkin here at the Department of Statistics, and with colleagues then in the Hive lab. We developed an algorithm whereby we were able to successfully decide if someone has COVID or not based on their cough. And I mean, that's fascinating research, because now you're thinking of a scenario in the next pandemic whereby you're at home and you cough and your Alexa says, hey, I think you have COVID-19 or COVID, 2025 or whatever it is, or whatever viral cough disease or flu. And then it says you should go for a screening test or PCR. So we're going to see interesting uses of things in medicine and in our physical world and scientific world that we haven't even thought of yet. And it's about bridging those two worlds, which is going to be a real opportunity for innovation.
Absolutely. And I suppose that brings me to artificial intelligence. And I mean, that's really exploded in the last number of years, particularly recently with the Chat GPT app and interest in that. So I suppose, what are your thoughts on that area? And obviously, it's ripe for innovation in medicine as well.
It is, yeah. So I was honoured to give the Royal Academy of Medicine lecture at Christmas last year. So delighted to do that and to be invited by my peers to give that lecture. And in that RAMI lecture, I spoke about these large language models and their potential. So one of the challenges is their veracity. How good is the data that they've scraped from the internet? And at the moment, the internet is the data they've scraped is limited to 2021. But even still, if they looked at, millions of websites, how accurate are the websites that they looked at? That's the first thing to bear in mind. And there's already been examples shown that ChatGPT maybe sometimes creates fake references or, doesn't actually explain things well. But I mean, overall, if you're to look at it in the round, the development of the large language model and the availability of it to the general public, as has happened with ChatGPT from OpenAI, is absolutely phenomenal. That's the first thing. So if any of your listeners have not explored that world in the last 6 months, they should definitely spend some time on the OpenAI website and in that world of reading about ChatGPT, because it's phenomenal. That's the first thing. The next thing then is how it's going to integrate into jobs that we do already. And I should say as well that, I'm not a technology evangelist. I think that there is a role for technology in our lives to make our lives easier. So I would be a big proponent of the 4-day working week if technology can do the work on the 5th day, basically, to make us more efficient. But only if it does that, if that makes sense. So with this AI, for example, this Chat GPT, which is a general pre-trained transformer chat large language module, meaning you can interact with it in chat format. That allows you to basically ask it a question and it synthesizes the answer from all the different websites. So the best example I can give you is if I said to Google, Google, here's seven symptoms that a patient has on the ward. What's going on? So what Google would do is it would basically list about 30 websites where those keywords appear on, a particular website. And maybe some of those websites then say this disease is infective endocarditis with that constellation of symptoms. But you'd have to click into the website and read the page. What ChatGPT does is, again, you type in and you say, a patient presents with these 8 symptoms. What is going on? Or what would I do? What it does is it goes away to all those websites and it synthesizes the data into a logical format or answer, whereby now it actually says, here are the 5 things it could be in order of triage. Here is how you would work up those 5 things, what test you would order. And here is the management of those 5 things if it is one of those 5 things. So its synthesis power is what's amazing. And there's a lot of applications for it. So one really exciting one we're working on at the moment with a commercial partner is that there is a massive healthcare worker shortage. So the World Health Organization reckons by 2030 will be 18 million people short of healthcare workers than what we need. So there just isn't enough humans in the pipeline to provide the care that's needed in the future, despite our best efforts to attract people into STEM subjects, science, technology, engineering, medicine, and math. There just isn't enough pipeline. And we have to double down our efforts through our outreach work, which we can talk about in a second. But essentially, we need the assistance of technology to allow us to deliver the healthcare to the growing population that's there. So as I said, it's about 6 or 7 billion now, soon to be 8 billion people on the planet. And a lot of those people are living longer because healthcare is doing such a good job. People who used to die in their 60s and 70s are living into their 80s and 90s, thankfully. But that comes with the added burden of disease. So one of the opportunities, for example, for ChatGPT that we're exploring is that, again, at clinic, if a patient needs advice to start on a new medication, rather than delivering the advice in person myself or one of my team, like the nurses or one of the clinical specialists, is there a way for that education to be delivered using ChatGPT with, for example, a digital avatar? And we're exploring that at the moment. We're doing a big trial at the moment. We're partnering with a major company in New Zealand who've developed this amazing technology for photorealistic avatars. So that, coupled with ChatGPT and the AI, as you mentioned, is going to open a whole new world of opportunities to do really important healthcare work, to allow the existing human clinicians to work higher up their license. And it's going to be really transformative, and also more equitable. It'll provide health education in places where that's just not accessible. And that's AI's real promise, I think, in that, like, for example, last year we developed an algorithm here at the University of Galway using AI, using neural networks, that was able to grade an ultrasound nodule of the thyroid as benign or malignant. In other words, does it need a biopsy or not for definitive? But we were able to grade as good as a consultant radiologist over 90% of the time we got it right. I mean, that's phenomenal. So therefore, you don't necessarily have to be at one of the great cathedrals of medicine in Boston or, in London or any of the big cities where there's a lot of resources, a lot of expertise. You can now be in a rural clinic in Kenya, hold up a ultrasound probe to your neck, and then the software will run with the same diagnostic quality as a radiologist from one of the big hospitals, and says, yes, this should be biopsied, I think it's cancerous. And it's the same in dermatology, it's the same in ophthalmology, all of the image-based specialties. AI have a big promise there. Now, obviously, there's a lot of conversations going on, and I think it's really important about the ethics of it. So how are these neural networks trained? What data sets? So if all your data set that you trained your neural network is in a Caucasian population, and then you use it on somebody that's dark-skinned, the error rates go up. So that all that stuff is really important to talk about and to get it right. So that I do think there should be ethics panels for AI, because a lot of the times we don't know how the AI is coming to its decision. And therefore that's big ethical problems then, if you don't know how it's coming up with its decisions. So there definitely should be oversight of AI. And actually, I'd probably be in agreement with a lot of the players in the AI world. Is kind of divided down the middle. Half people say, yeah, let AI have it and let it do what it wants. But there is a half of people, I think, with probably greater insight that say there should be some kind of regulation of AI. And we don't mean regulation to stop it. What we mean is, before you eat food, it has to be assessed by a government panel to say that food is edible. Before you take a medication, someone in the chain has checked to see that medication meets a certain standard of quality and its efficacy. It actually does what it says. And AI is no different. So again, what you're probably going to see in the US is the emergence of a federally mandated agency to monitor and to allow AI to be used in healthcare. And I think that's ultimately a good thing, So as much as people think self-regulation works, usually it doesn't. So it's good to have oversight. I think that's going to be important. So AI is going to be really exciting in the future. And I think anyone who doesn't use it will be left in the past. And I think it's something that should be embraced to make us better clinicians, to provide better care. It's going to be really transformative in medicine, and it's very exciting.
It is very exciting, and all the projects you spoke about in this episode are really exciting. And I could talk to you for hours more, because the sky is the limit, really, when it comes to innovation in medicine from what you've told us about today. But alas, we're going to have to finish up. So that's a wrap. Please keep tuned for further episodes in this series of the Innovation in Healthcare podcast from the Medical Independent.
That brings us to the end of this episode. Thank you for tuning in. Please subscribe to The Medical Independent for the latest healthcare news and debate. Sign up at www.mindo.ie to stay up to date on all the latest medical news. Join the discussion on Twitter at med_Indo News. Introducing the new Medical Independent app. Why not join over 14,000 healthcare professionals and stay up to date on the latest healthcare news in Ireland? Read in-depth reports on the issues impacting the health service and medical professionals. Trusted insights, breaking news alerts, in-depth analysis and more. Download the Medical Independent app on the Apple Store or the Google Play Store by searching the word Mindo. The Medical Independent app. Your news, your way.